You know, we all use the internet, but underneath that chaotic sea of information, there's actually a set of rules. It's kind of like a universal rulebook that helps machines make sense of it all. So today, we're going to unpack that rulebook, RDF Schema.
To get a feel for this, just picture this. You're standing in the biggest library imaginable. Every book ever written is on the shelves, but they're just in random piles. No catalog, no sections, no order whatsoever. Total chaos. How on earth would you find anything?
Well, that chaotic library, that's a perfect way to think about how a computer sees the World Wide Web. It's just surrounded by billions and billions of facts and figures. But without some kind of shared system for meaning, it can't figure out how any of it connects. It's all just a jumbled digital mess.
So Section 1, a library without a catalog. Let's start with that core problem. How do you possibly bring order to all that chaos?
The answer, it turns out, begins with the smallest possible unit of meaning. I mean, before you can build some grand organized system, you first have to be able to make just one single simple statement. Which brings us to Section 2, the first index card. That very first building block, our first index card for this massive library, is a technology called RDF, which stands for the Resource Description Framework. RDF works by making these really simple statements called triples. And just like a basic sentence, they've got three parts: a subject, a predicate, which is kind of like the verb or the relationship, and an object. So we can say Mona Lisa, subject, was painted by, predicate, Da Vinci, object. It's simple, it's clear, and it's something a machine can perfectly understand.
Ah, but here's where we hit a snag. Our RDF triple is just a statement of fact. It doesn't tell us what these things are. Is Da Vinci a person? Or maybe the town he was from? Is the Mona Lisa a painting? Or, I don't know, a book about the painting? Our little index card is helpful, but it's missing some pretty crucial context.
And that brings us to Section 3, the rulebook for data. This is where we have to go one level deeper. See, we don't just need the index cards, we need the rulebook that tells us how to categorize them. And that rulebook is RDF Schema, or RDS for short.
The official W3C specification puts it this way. RDF Schema provides a data modeling vocabulary. Now, in plain English, that just means it gives us a shared official set of terms to describe the types of things in our data and the types of relationships that connect them.
And to do this, RDF Schema gives us two main tools. Now, these are the absolute rock-solid core concepts for creating meaning on the web. We're talking about classes and properties.
A class is, well, it's pretty much exactly what it sounds like, a category. You know, just like a library has sections for history or science, RDFS lets us create classes like person, document, or painting. So now, finally, we can officially state that Da Vinci belongs to the person class.
And a property, that defines the relationship itself. It's the was painted by part of our statement. We can create these super specific properties like has author or was born in to describe exactly how two things are connected.
All right, Section 4, how the rules actually work. So we've got classes and we've got properties. But the way RDFS combines them is, well, it's a little counterintuitive. And honestly, that's the key to the whole system. This is the big aha moment. Okay, here it is, the crucial difference. In most programming, you'd probably start with a class, right? Like book. And then you'd give that class some properties, like author. The property belongs to the class. But RDF Schema, it flips that whole idea completely on its head. It is property-centric. You first define a property like has author, and then you define what kind of things it connects. And this property-first approach is exactly what makes it so powerful for the web. As the spec itself notes, it allows anyone to extend the description of existing resources. Because the properties are independent, you can come along and create a brand new way to describe something without having to ask for permission or change its original definition. It makes the web's data truly collaborative.
So how does this work in practice? It uses two really simple rules. The first is called RDFS domain. The domain basically says what kind of thing can be the subject of a property. So for our hasAuthor property, we'd say its domain is the class document. The rule is only a document can have an author. Simple as that.
And the second rule is RDFS range. This, as you can probably guess, specifies what kind of thing can be the object. So for has author, the range would be the class person. The rule here is the author must be a person.
So, by putting together a property with a domain and a range, we've created a complete, logical structure a machine can finally understand. It now knows that if it ever sees the has-author property, it is looking at a statement that connects a document to a person. The ambiguity is gone.
Okay, Section 5, why this changes everything. So we've got these rules. It's a little technical, but why does this actually matter? Because this simple set of rules has really profound implications for how the entire web works.
This whole property-centric model, it's what makes a true interconnected web of data even possible. It lets different systems understand each other's language. It allows anyone, anywhere, to add new descriptions to existing data. It can even help automated tools find errors by checking if those domain and range rules are being followed. It's huge.
All right, now prepare yourself for a concept that gets a little mind-bending. It really shows you how deep this system goes. So, in the world of RDF, everything is a resource, basically a thing that can be described. And that includes the very classes we use to do the describing. So, the class person is itself a resource.
This leads to this really fascinating kind of circular question. There's a special class, RDFS class, which is the class of all other classes. So our person class is an instance of RDFS class. But if RDFS class is also a class, what class is it an instance of?
And the answer is, it's an instance of itself. Yep, you heard that right. RDFS class is a member of its own set. Now this might feel like a weird paradox, but it's actually this beautiful, elegant, logical loop that lets the whole system exist. It is the ultimate meta rule. It's the rulebook that contains the rule for how to be a rulebook.
Which brings us to our final section, the ultimate question. So, bringing this all together, RDF and RDF Schema, they aren't just technical acronyms. They're the foundation for a web where machines don't just display information, they actually understand it. And that leads us to one last, really powerful thought. We now have the blueprint for a semantic web, a web where all data is linked together and has real meaning. So the real question becomes, what do we build with it? What new realities, what scientific breakthroughs, what kinds of creativity become possible when our machines can finally grasp the context behind all of our data? That is the future this rulebook unlocks.